Dear learners, I welcome you all to this session. Today's session is the component of part B of the course BCOC 134, which is Business Mathematics and Statistics, and part B is Business Statistics. So today we are going to discuss part B of it, which is Business Statistics, and to begin with we'll start from the chapter which is Measures of Central Tendency, right? So let us see. What is measures of central tendency and why do we measure it, right? So suppose, first of all, when we are talking of statistics, that means we have to deal with data. Data means information, right? So what is statistics? Statistics is, collection of data, classifying it, tabulating it, analyzing it so that you can draw some inferences out of it, which can be used. And when I'm talking of business statistics, that means those information which is useful for business, maybe when we are trying to collect that data, tabulate it or classify it, and then we are applying some statistical tests so that we can analyze it properly and we can draw some kind of statistical inference which is used in the business, right? So we do this. So we have to understand what is the nature of data first. If we know the nature of data, then only we can treat the data, or then only we can apply some statistical tools to get the inference out of it. So for all those things, it is very important to understand the nature of data, right? So when we are talking of central tendency, that means it is a value that explains the entire data set. Let us try to understand the measures of central tendency with a very common kind of example, and then we'll come to it one by one. Suppose I have this bag, right, and it contains currency notes of several denominations, okay, and you want to know what is the amount of money which is there in this particular bag, right? So there are two ways. Either you take all the money out, you calculate and you try to find out that this is the amount of money, maybe 10,000, 1 lakh, 10 lakh, 1 crore, whatever it is. This is the amount which is there in this particular bag. Or maybe the other way, suppose if the data is small, then you can do that. But if the data is big, if the information is big, then in that particular case, what you need to do, you need to know two things. One, what is the size of the population? That means what is the total number of currency notes which are there in this particular bags, number one. And number two, what are the various denominations of notes which is there? And three, what is the average of the denominations, various denominations, right? Or which denomination is coming most of the times when you are drawing one note from this particular bag, right? So say for instance, you are drawing one note and it gives you a denomination of 100. You are drawing another note and it is giving you a denomination of 100. The third note, when you drew, it again give you the denomination of 100. Fourth, when you are drawing, maybe it is 500, or sixth it is 2000, seventh it is 50, so on and so forth. So out of 7 times when you withdrew the money from this particular bag, what is happening? 4 times we are getting a currency note of 100 denomination. That means what? On an average, the currency notes which is there in this particular bag is of what denomination? Denomination 100, right? Is it okay? So measures of central tendency is nothing else but it explains the central part of the data. What is the data and how would it look if you try to divide that particular part of the data from a midsection? What shall be the nature of the data? How would it look, or what information would it provide? So we can say that central tendency is a statistical measure that gives the best representation of the entire data set. This was the entire data set, but the best representation which was given was that most of the currency notes which was there in this particular bag is of what? Is of 100 rupee or 100 denomination, right? And it enables the user, whosoever is using it, or it enables the person who is doing all these things to summarize a large set of data into single value. And it also helps you to compare 2 or more data sets. For example, if I have another bag of the same kind and it also has the currency notes, and now you want to compare which would be having more amount of money, right? So again, we need to check the average currency note or more frequently found out denomination from bag A, this bag, and the same for the bag B which is kept. Say for example, when there is another bag which is kept somewhere in the drawer, and when you are drawing currency notes from that particular bag, what is happening? Out of 7 times, 5 times or 4 times you are drawing 500 notes, and 6th and 7th times when you are trying to withdraw money or draw money from that, the denominations are different. That means from this particular bag the average was 100 rupee note, and the other bag the average was 500 rupee note. So on an average, or maybe you can say by and large, you can say that the other bag, maybe which is kept in the drawer, has more money than this particular bag. So this way, when we talk of measure of central tendency, it also helps you to compare 2 or more data sets, right? It can also be called as measure of location or statistical average. And when we are talking of this measures of central tendency, the methods through which we can find, or the methods through which we can measure the center point of the data are usually 4: mean, median, mode, and mid-range. Since mid-range has the potential to be more biased in nature than the other three which is mean, median, and mode. So mid-range has potential to be more biased than the other 3, which is why it is not used as it is the average of 2 extreme values that can be the outliers. We will understand the concept of outliers also in the coming session, or maybe in due course of time when we are progressing further in this session. So this will always be larger than the other statistical averages. That is why, this is one of the reasons why we don't use mid-range as the measure of central tendency, and we give importance to 3 important methods, which is mean, median, and mode, right? Shall we move further? All right. Before we come to the mean, median, and mode, to understand what is mean, median, and mode, why it is used, when it is used, and how is it computed, right? What is the method to calculate median and mode, or compute median and mode? We need to understand what is data set, what is data point, and there are certain concepts which you need to understand before we jump to the computation of mean, median, and mode. So we'll start with data set. Often when we talk of statistics, often when we talk of researches, we say or we use a term which is known as data set. So what is a data set? Data set is the ordered collection of raw statistics, information, or data. So whatever data or information that I have collected, the entire data is called as data set, and the values in the data set is called as datum. Each and every value which is there. Say for example, I have tried to know maybe the income of say for example the managers in a particular company. What is their average income per month or per year? So when we have collected data, so somebody, maybe Mr. A, suppose that organization has 10 managers. I'm just giving an example, right? Suppose there are 10 managers, and manager first or manager A, right? His or her salary is maybe 1 lakh a month. Manager B, his or her salary is 70,000 a month. Manager C, manager D. So likewise, average salary of the or maybe salary of the each and every individual, 10 individuals, right? Whatever the data would be, it will be called as data set. And when we talk of salary of Miss C, say for example, salary of Miss C is 2,10,000. Then the salary of Miss C, this particular value is called as datum, which is the value of an individual, right? Now, what are the various kinds of data set which is used in statistical operations? There may be numerical data set, there may be bivariate data set, there may be multivariate data set, and there may be categorical data set, right? What are those? There may be 4 kinds of data sets. One is numerical data set, second bivariate data set, third multivariate data set, and fourth is categorical data set, right? So before we understand again each and every kind of data set, let us quickly see what is data point. As I said, the entire set of information is data set, but data point is the singular form of data, right? That is also called as data items, or by and large you can say datum. That is what? Data point. It is one piece of information about an observation at one point of time, and or you can say that it is one cell in a data table, right? So that is data point. Now let us see what are the various kinds, as we have discussed before. What are these kinds? What is numerical data set, right? So numerical data set, as the name suggests, numerical, that means numeric values must be there. So when the data is represented in numbers, it is called numerical data set. As for example, I have at the very beginning, at the outset only, I gave you an example of maybe average salary of 10 managers in a company. So the data is represented in numbers, that is numerical data set, right? It can also be called as quantitative data. And when something is quantitative in nature, what we can do, we can perform arithmetic operations on it. All kinds of arithmetic operations we can perform. We can add, subtract, multiply, divide, whatever you can think of, right? We can perform on these kinds of data set. So if we take example of numerical data set, maybe if I'm talking of, as I said, the monthly income of the managers, or maybe height and weight of class 7 standards student, or the annual yield of crops in a particular state. So all these kinds of information will be numerical data set, right? So now let us come to the other data set. The other data set can be a bivariate data set. So when we say bivariate, that means bi means two, variate means we are talking of variables. So when we say data set with two variables, this is called as bivariate data set, and it deals with the relationship between the two variables, right? It usually contains two types of related data. Say for example, if I say when price of commodity X, or when I say the price of this eyeglass, right? When this is changing, the quantity demanded of this particular commodity is changing in case this is a fashion statement. If it is need based, the story will be different, right? The whole scenario would be different. But if it is it is used for fashion statement, suppose it is not giving you any other value other than giving some kind of fashion statement to you. In that particular case, if the price of this particular commodity, price of this eyeglass, if this is increasing, there is change in the quantity demanded of this particular eyeglass, right, which is also called as law of demand. This explains that. So when this kind of data is there, say for example, when the price of this eyeglass was rupees 2,500, the quantity demanded of this particular eyeglass was say for example 1 lakh units. The moment price increases from 2,500 to say for example 3,500, the quantity demanded is decreasing. In place of 1 lakh, maybe it decreases to 80,000 units only, 80,000 eyeglasses only. So this, when two sets of data points, one set is what? The price of this eyeglass, and the other set is what? The quantity demanded for this particular eyeglass. So the data sets are two, one for the glass and the other price of the glass, and the other for the quantity demanded for that particular glass. So this kind of data is called as bivariate data set, right? We try to see, or we can see some kind of relationship between these two variables, right? Now let us move to the other kind of data set, which is called as multivariate data set. Bivariate data set, we were talking of two sets of data. If there are more than two sets of data, then it would be called as multivariate. Multi means many, more than two, right? So multivariate is what? Data set with multiple variable is called as multivariate data set. 3 data set, or maybe more than 3 data sets, or maybe more than 3 variables, right? That will be called as multivariable data set. Such as when I say change in income of individuals, change in the price of a particular commodity, and change in demand. It can have various impacts. The data set can be very many. Like change in income will be one data set. Change in the price of the commodity will be another data set. So, and change in quantity demanded of that commodity is another data set. And maybe at the same time, if the substitute or complementary products prices, they are also changing, they are also fluctuating, then that will be another data set. So, if there are, again, just to emphasize it more, why I am trying to emphasize it more and more, because of two reasons. One, that you should understand it fully before coming to the computation part of the mean, median and mode, or any kind of statistical operations or tools that we are talking of. We need to understand these concepts. And number two, there are many learners who don't have the background of commerce, right? So, for them I am trying to simplify the things, right? So, again, when we have more than 3 variables, 3 or more types of data sets, then it becomes multivariate data set. Now, let us see the other kind, which is categorical data set. As I said, the other 3 which I was talking about, they were all quantitative data set. They were numerals, they were numbers, and we can do any kind of mathematical operations on that. But there is kind of data set, which is not in numbers. It consists of categorical variables, or suppose when I am talking of features or of a particular commodity or service, or characteristics of a person or an object, that comes under categorical data set. Since it is categorical means either I can say this is the first child or this is the first student who has entered in the class, and so if I am giving a name, so for example, Arnav is the first student who has entered into the class, and Sanvi is the third student who has entered into the class. So, first and third, these are just categories, right? It does not mean 1 and 3. When I say Arnav first is 1 unit only, and when I say Sanvi third or fourth, it is again 1 unit only, but the categories are different. It is order of something, right? Or in the same way, when I say that composition of boys and girls in a class, so these are kinds of category or categorical variables. So when the data is comprising of these kinds of categorical variables, it becomes categorical data set. It is also called as qualitative data with 2 values, right? Since it has 2 values, it can be termed as a dichotomous variable also. What if there are more than 2 variables? There may be 3 variables, there may be more than 3 variables, then it will be termed as polytomous variable. For example, if I am trying to find out the gender of a person, male, female, transgender, or maybe the marital status of an individual, married, unmarried, widower, divorced, separated, etc. So, more than 3 variables. That means it is called as polytomous variable. So, categorical data set may have dichotomous variables or it may have polytomous variables. 2 variables means dichotomous variables, and 3 or more variables means polytomous variable. Again, in this kind of data set, no arithmetical operations can be done, right? Because they are only categories, they are not numbers. However, we can see the difference, we can compare the, for example, if I say in the BCom examination, what is the performance, average performance of boys and girls? So, say for example, performance of boys, if I am saying performance of boy is less good, I won't say bad, less good than the performance of girls. Don't take me as a gender biased person, it is just an example, right? Or maybe vice versa. The performance of boys is better than the performance of girls. So, what is happening? We can see the difference. This is more and this is less, but we cannot see the magnitude of difference. How much less? How much more? Because it was just the categorical data. Had it been numerical data, we could have also, along with the differences, calculated or understood the magnitude of difference. So, that is categorical data set. Now, let us quickly understand what are the properties of data set, because unless we know the property or the nature of data, we cannot treat it, we cannot use adequate or proper statistical methods to treat that data, to analyze that data. Data treatment means data analysis, and you can only draw some inference when the data is analyzed. The data is collected, presented, tabulated, whatsoever, but unless it is analyzed, you cannot draw meaningful inferences. So, for meaningful inferences, we need to understand the property of data first, so that we can treat it properly, right. So, to understand the nature of data, since nature of data is very important for data analysis, so we need to understand it. So, to understand the nature of data, we need to see the properties of data, right, and this can be done with the help of exploratory data analysis, right. So, there are various methods, or there can be various properties which can be seen in a data set. So, those properties is center of data, which is also called as, we are trying to measure the central tendency of the entire data set, or the data set which is center of data. We should also know the skewness of data. All these terms we will understand in the other sessions, right. We will stick to the measures of central tendency only to this and the coming sessions, right, the immediately coming sessions. So, center of data, skewness, spread of data, or presence of outliers. Presence of outliers means, when I was trying to analyze the difference, or when I was trying to see the average income of the managers in a particular company, and I found that on an average, or suppose for example, if I find that the A, B, C, D, E, F, G, these individuals, maybe 10 individuals, first, second, third, fourth, fifth, all these individuals, they were ranging from, say for example, 1 lakh to 2 lakh, right. But out of the 8 data was ranging from 8 to 10. But in the same category, in the same category of managers, maybe if somebody is there who is drawing 30,000 salary, and the other manager who is there, that is the extreme low value, right, and the other manager who is drawing, say for example, 10 lakh salary. So, there was a normal range of 8 data that was from 1 lakh to 2 lakh. The minimum or the least one was which one? 30,000, and the extreme was 5 lakh. So, if we add these two data of these two managers also, the average income which we will get will be misleading. It will be much higher than what the actual average should be. So, these two are called as outliers, exceptionally low or exceptionally high values. So, when we are doing some kind of analysis, we need to eliminate these kinds of data which is known as outliers, then only we should try to analyze it. So, we need to understand, we need to check whether there is a presence of some outliers or not, so that we can get the close to accurate results. And then correlation among data, we can see whether there is some kind of correlation or not, and the type of probability distribution. So, this was the properties of data set, right. Now, let us see, let us understand the important measures of central tendency, like mean, median and mode, right. So, as I said, there are 3 methods of knowing or measuring the central tendency: mean, median and mode. And mid range we are not using, or generally it is not used for a particular reason, which we have explained, or which we have discussed at the outset of this session only. So, we will start with mean. So, what is mean? Mean is nothing but statistical average or arithmetic average. Average may be very many, not only arithmetic, it may be harmonic, it may be geometric. To understand, by and large, mean is what? It is statistical average, right? That is mean, and it gives an overall idea or picture of the entire data set. Okay, what is the average of this particular data? And it is also the most important value when data is scattered without a typical pattern. Suppose there is a typical pattern in a data set, then fine, but if there is no typical pattern, then it becomes very important to understand the average data, average information, on the basis of which we can draw some inferences or we can take certain decisions, right. And it includes every value in the data set as part of calculation. Even when we are talking of the 3 methods of central tendency, mean, median and mode, mean is preferred in many cases because of the nature, because it includes every value in the data set which is present, which is a part of calculation, right. So we have seen mean till now. In the next session, we'll discuss about what is the use of mean and how to compute or calculate mean. What are the various methods? Okay. So for now, we are ending this session. Let us catch up in the next session. Till then, keep learning. Happy learning.